Hello again, video number 8 for flipped geometry now, and this one is an interesting one because we start talking about a friend of mine named pi. And pi is one of these symbols in mathematics that we often take for granted. I think my friend Mr. Winograd certainly is well aware of pi. I think he has pi memorized up to something like 100 places of decimal. You can ask him about that. But what I want to do today is actually explain what pi is. Okay? So first off, this is the symbol for pi. So if you want to write pi, it's just pi, but we often just draw this symbol. So there's a squiggly line followed by the two lines coming down like that. So that's the symbol for pi. Most of you probably have spoken at some point or heard at some point that pi is equal to 3.14. Now that 3.14 is an abbreviated version. It does keep going and going, and as I mentioned, Mr. Winograd is very familiar with connecting all of those numbers and memorizing all the way up to the 100th place of decimal. Anyway, we're going to just stick with the to the 100th place itself here, so just 2 places of decimal for us. Anyway, let me explain. So here we have a circle. As I showed you in the previous video, we talked about this being the diameter of the circle. Now, pi is a relationship, it's a ratio between the circumference of the circle, in other words, the distance around the circle, and the diameter itself. So there's a ratio happening there. So in other words, as the diameter grows, so does the circumference. Kind of makes sense. So as the circle gets bigger and bigger and bigger, the diameter gets bigger and bigger and bigger. And then as we shrink, the diameter shrinks, the circumference shrinks as well. So how do we end up with this 3.14? Well, here's the thing. A single diameter of a circle, if you take that diameter and put it end to end around the circumference of the circle, guess how many times it fits? Well, let's see. I tried to match it up. So here's our diameter on the inside. The first diameter I drew was here. If that's a single diameter there, here's the second one. So the first one went from this point to this point. The second one goes from this point to that point. And the third one goes from there to here. So there we have 1, 2, 3 diameters. That leaves us with this small section right here. You guessed it. That is the decimal section there. So if we add all that together, 1, 2, and 3, we get 3 diameters plus that extra little 0.14 and so on and so on. So the combination of 3.14 diameters equals the actual circumference of the circle. So in other words, if we use pi being 3.14 for a moment, and we said 3.14 multiplied by our diameter, that's going to equal the circumference. We'll use D and C for diameter and circumference. Now, you know that through our work with algebra, we can make sense of this by simply saying, well, if we want to get pi on its own, we need to get rid of the D. We need to essentially divide the whole thing by D. So if I do that right now, if I divide the whole thing, I'll be green. Divide the whole thing by D, that means because it's an algebraic equation, I want to keep the balance. I want to divide both sides by D. Those D's will cancel out, and that simply leaves us with pi, or 3.14, is equal to the ratio of the circumference over the diameter, which is where we started. So pi is equal to the ratio of the circumference to the diameter. Pi is equal to the ratio of circumference to the diameter. The key understanding here is that it is a ratio, that as the circle grows, so does the diameter. As the circle shrinks, the diameter's relationship to that circumference maintains that same ratio. This idea that a diameter fits exactly 3.14 times around the outside of any circle is the relationship between those two things. So that is your explanation of pi.